Um, so we direct, I'm Shunya from Google Chrome. We direct to start the continuous conversation for the resource timing API update for the static routing API. Lastly, we had a WebPerf call maybe in July. So today, yeah, Keita will give a presentation. It would be great to have a time to follow-up discussion. Thank you.
Yeah, thank you. Yeah. So hi, I'm Keita from Chrome browser loading team, based in Tokyo, and yeah, we would like to talk a little bit more about the resource timing for the service worker static routing APIs. So okay, so here's the agenda. So we're gonna be, since this is a continuous talk from the last discussion we had, we would like to do a little recap on what static routing API is and our original proposal and the feedback that we got. And then we're going to be doing the latter half will be talking about what kind of action we took and a couple of discussion topics that we would like to have with everyone and get feedbacks. Okay, so what is Service Worker Static Routing API? Well, as many of you probably already know, Service Worker provides an application-like behavior to the web, and it can provide flexibility to developers. But because of its nature, Service Worker typically exists in a navigation critical path. And because of its complexity, the bootstrap is known to be pretty heavy and may incur high overhead. This is problematic, especially because it causes high navigation latency, and there were a couple of efforts to actually reduce that. So Service Worker Static Routing API is one of those efforts that attempts to mitigate this latency by allowing developers to control how certain resource paths are actually fetched. In a nutshell, or when a router rule, so developer actually provides router rules and specifies which resource are actually going to be fetched from where. And when that's actually provided, the router evaluator over here actually checks each path and its roles where it corresponds to, and fetch the resource from there. Currently, we actually have 4 primitive path roles, which I'm going to be talking a little bit here. The first one is the fetch event, which is basically, it actually works as basically the same as the service worker fetch. The static the router actually forwards the request to the service worker, and then the fetch handler is going to fetch the resource. Yep, just like that. Yeah. Okay, so and the second one is the network request with network rule, which instead of actually enabling service worker, it directly calls the network request without any interference from the service worker. The third one is the cache rule. With the cache rule attempts to get cache resources from the cache API. If there's a resource already available there, it's going to be fetched from there. And the last one is the race fetch and network rule. So this one actually calls both fetch rule and fetch and network request both at the same time, and then uses whichever request that actually comes before come first. So we have these 4 path rules, and the behavior is a little it's kind of like this. So as I showed you a little previously, there are many components involved in static routing API, and there are actually multiple possible behaviors which the static routing API can actually take, including these path rules. For example, like the race rule, we don't really know which fetch handler or the network request handler, we don't really know which one actually comes first or not, and the behavior may change from there. And because of this, the behavior of these components may be unclear to the developers themselves, and which might be problematic when actually optimizing their websites to use the static routing API. So for instance, we currently don't know how long, we don't actually expose how long the router evaluation actually took per resource. Or we don't really know which path is actually used. As I explained earlier, for example, race rules, we don't really know which one actually, developers can't know which path actually won and where the resource actually came from. Or another timing info, it would be how long did the cache lookup actually take? If it's actually worthwhile specifying the cache lookup rule or not. So given these circumstances, our original proposal was to expose a couple of key factors to and add them to the resource timing API so that developers can have some level of exposure to these information. In detail, we originally proposed to make 4 changes, 2 new timing information, worker router evaluation start and worker cache lookup start, which both corresponds to when the router evaluation lookup actually, when the router evaluator actually started evaluating, and when cache lookup actually started. In addition to these 2 timing informations, we proposed of adding 2 new fields, which is matched router source type, literally the actual source type, the matched source type of the route, and the actual router source type, which corresponds to where the resource actually came from. Now, given these proposals, we had a chat with Web Performance Working Group, and we actually got a couple of very valuable feedbacks. Some of them are listed right over here. First one is, how beneficial will the timing information actual will be? The next one is, the naming should be actually consistent. And then the last 2 are something that's will be a problem when we actually use cache, but that's the rule. But so one of them is fetch start should be response store, and like another one is the delivery type. What would be the appropriate delivery type when the resource actually came from the cache? So I'm gonna go over a little bit one by one and the action we actually took. So the first one is how beneficial will the timing information actually be the worker router evaluation start and the cache lookup start. We actually, after the discussion, we actually did a little bit of more further research and surveying, and took a couple of actions for that. And our current decision, in a way, is one, is to not include worker router evaluation start, at least in the initial spec. We're going to be showing you a little bit more why we think that later on. But yeah, because the router evaluation might not be that much of a significant impact on actual behavior itself. And the second one is to expand the cache lookup start scope from being solely into static routing API to actually looking into more cache API access in general, so that developers can actually have more benefit from actually looking at the time. We will be again, we'll be talking a little bit more about these 2 fields, and we'll be happy to get more feedback on them. And for the naming and the fetch response, these are very simple changes. So we've kind of updated the explainer just like by appending fields, making it a little bit more consistent, and setting a fetch start. So our original proposal was to have it 0, but because of compatibility issues and everything, we decided to align it with response start. And the last one is, this one actually came from suggestion from the working group as well, is to consider adding new delivery type, and setting that as the type when the response actually came from the cache API. Again, this will be another discussion topic if we'd like to talk a little bit more. But our current suggestion here is to introduce like a new value to delivery types, for example, like service worker cache or something relevant, so that we can actually differentiate from the current cache, HTTP cache value that we have. And also indicate to the developers that this actually came from cache API. So yeah, these three are going to be the topic that we're going to be talking a little bit more. First one again is our decision on removing the worker router evaluation start time. First, we want to talk a little bit more about this and why we think it's not worthwhile in the first initial spec change. So the upon our survey, we found out that the router evaluation time is most likely be negligible for developers. If you actually look at the oh sorry, it's a little hard to see here, but the figure on the left corner shows the orange line shows the total sub-resource, total router evaluation time it took for all the sub-resource within a navigation. And the blue one suggests the evaluation time for every single resource within a navigation. So if you actually look at this graph, the 90 percentile is approximately 13 to 14 microseconds, which I believe is very, very small compared to like the millisecond order of the actual navigation overhead. Because of this like very small overhead it incurs, we think it's not worthwhile actually adding them in the initial spec change, but keep in mind that this data is actually pretty highly biased to a large traffic site, since the static routing API is still a newer feature that is, I think, progressively being adopted yet. So yeah, while we don't think it's worthwhile for the first change, but we do think it might be worthwhile revisiting after wider adoption. And FYI, the figure on the right-hand side shows how many router roles actually each website has, and it's basically one or two, so it's very, very small. So that's the discussion on the router evaluation start. Going on to the cache lookup start. Again, we actually did a little survey on how many sites actually use cache lookup start in general. Unfortunately, we couldn't find our survey couldn't find any sites that actually use cache lookup yet. Again, because of probably for the high bias here, but and it's progressive adoption. So it's still questionable if it's actually usable or not for static routing itself. However, we do believe that these information cache lookup start time would be beneficial for the cache to actually expose them to cache API lookup in general. For example, when the service worker fetch handler actually retrieves that response from the cache API, so that it can have some exposure to developers of how much actually time it actually look for the cache for the set type to actually look into the cache. So we are thinking of expanding the field to instead of being solely into static routing API, we are thinking of expanding the field to cache API lookup time in general. And this is also suggested in the last discussion in WebPerf working group as well. But we do need to have like a couple of considerations, including what happens if like cache API access happens multiple times, or are we actually going to record it regardless of if we actually the cache API's response actually is used for the response width or not, and we would like to get a little bit more feedback on that. Yeah. Okay, and lastly, the discussion that we would like to have is the introduction of a new value and delivery type. So we kind of upon discussion with the WebPerfWG working group last time, we might want to have a new value, a delivery type property that mentions that the response actually came from cache API or not. And we already have a value called cache in the delivery type, which points to the HTTP cache, and not the cache API. So we are sort of thinking it might be beneficial for developers to actually have values like service worker cache as a new value and have it set in the delivery type when it actually comes from that. Again, there's probably a lot of more discussions that we have to have, including the name itself. The service worker cache is pretty ambiguous, as it can be also used outside of service worker. But yeah, that's also a discussion we would also like to have right over here. Yeah, so to sum up, the discussion topics that we would like to discuss here is actually worker router evaluation start beneficial or not, expanding the cache lookup start to caching API, and introduction of a new value to delivery type, if it's actually reasonable or not. Yeah, that's I think what we have right now.
Should we start recording?
Yes, thank you.
Let me do this phone thing again. Right. So this is about long animation frame, status and next steps, and also opportunity to hear things about it from the room. So it's shipped and in wide use by a few run providers, by a few big websites, internally and externally.
What does 1PS mean in this context? First parties.
First parties, yeah.
There you go. Okay.
And also, you know, Wix uses it internally, so that thousands of websites. So it's difficult to say like who is the first party and who is the third party, but a lot of people use it. We get a lot of feedback for it from people who are using it in practice for production. A lot of feedback about we used it and we found the script that actually was causing things to be bad. There are third parties that have programs to improve things, and they use this to like all kinds of ad providers that use this to see if it's their fault that the site was slow. So cautiously declaring the last year with this a success. Yep. So now all websites are more responsive, and we can stop. No, of course, like with any new API, we did see a few pain points with it. Some of it we knew when we were developing them, and we just decided, okay, let's ship something anyway, and like we'll fix them after because there's no clear solution. The first one we talked about 2 days ago, which is the wrong attribution with wrappers like Sentry, where you have a script that wraps everything, and it looks like that's the bad long script, but really it's something internal. So the main problem here is that lofts only give you the entry point scripts, and it's not always interesting enough information. I think currently the plan for it is after 2 days ago is to research what we can do with microtasks, because it's very hard to attribute internal scripts when microtasks are involved. Microtasks are weird. They get mixed together in the microtask queue from several sources and then run in the order in which they were added. And it's like an actual measuring problem for the web. Of course, microtasks provide a lot of other benefits, but they're hard to measure. So as the web performance group, we should find a way to measure how this works. It's the same today also with the entry points that are microtasks, that are promise resolvers, like fetch.something.then. or anything with streams. There are a lot of modern APIs that are promise-based. Luckily, most of them are actually a single task. The whole promise resolver is a single task that resolves to a promise. So what we do today is that we measure from the time the promise was resolved until the end of the task, or until the microtask queue is completely cleared. It's a bit not 100% standard way of doing things, and I want to flesh it out, but it's again, if we have something like attributing microtasks to where they come from, to the originator, this could also be a solution for this. The other pain point is that style and layout. We talked about this earlier today. Style and layout are somewhat of a black or purple box. At least in Chrome DevTools, it's purple. And the other thing is that we don't have presentation time for them. Like we have presentation time. Presentation time is after style and layout and after paint, like a compositor timestamp kind of thing. We have that in other places like paint timing and event timing and LCP, and we don't have it for each law in isolation. Next steps. We know Firefox are Gecko are really happy that you're showing positive resolution for it, and for both for you and for developers, we want to keep it relatively stable. We don't intend to make major changes in it anytime soon. So sometimes we have to just declare that this is the case. It's just not going to change much anytime soon. Maybe specific improvements to specific pain points. The big pain point that we'll explore is the CPAD thing. That's an internal Chromium thing, but it's really about this chain of microtask thing. We're exploring that performance.bind thing, so that which depends on the other thing, so that blame can be safely transferred to the right owner, and do some exploration around style and layout attribution, perhaps at presentation time. This is everything we're planning for in LOAF, and this is where we can stop recording and discuss what needs to be discussed. So I wanted a short one too.
Or the conceptual.
Recording in progress. Take it away, Colin.
Right. Hi, I'm Colin Bendel at Shopify. So I wanted to just talk quickly about some of the work that we've done with our own performance measurements and some of the results we've had, and a muse around Protobuf, and wanted to get some feedback and input on where we can take it further. So just as some context, we've recently shifted our RUM measurement collection, moving it from Boomerang to Core Web Vitals, or slight variation of the Core Web Vitals JS, which pretty large payload difference for us, because we had a forked version that was quite out of date. So we moved from a 20K payload down to a 6K payload. The interesting pieces, though, is that this resulted in a 2% increase in the volume of metrics. So steady state, really no change, but we just got a lot more metrics. And that has a corresponding impact of about 5 to 10% changes in our LCP that we were measuring across our merchants. So this is a clear example of survivorship bias and tipping the probability that the payloads land and the beacons are fired, that we can collect that data. In most of these cases, and this is on a case by merchant, looking at their LCP, that's why the range of 5 to 10% improvement. And in fact, many times it was an improvement. And so it was actually a good story at the end, that the data that we were missing in these cases were fast experiences. But that got me thinking and looking at what other ways can we help improve the survivability for analytics, particularly performance-related analytics where consent is given, and we want to make sure that we are presenting the best experience for our merchants, and that our merchants understand where what's happening for their buyers, and ultimately address that survivorship bias. So quick example of some of the payloads that we would be sending. Nothing too extraordinary, maybe a little bit verbose, but all the different nav timing and resource timing metrics that we beacon and gather up. So the question really was, can we use Protobuf instead of JSON as that payload? That payload sits at 2.5K at minimum, plus or minus a couple K, depending on a bunch of different circumstances. And because it's a beacon, can't use web worker and compressed streams. So for those who may not be familiar with Protobuf, a quick primer, it's basically JSON, just with a pre-shared schema. So you define a schema like this. So if you have a message, you define the different types and associate them with integers so that you have that Protobuf definition. So if you had a JSON object, typical quotes and curly braces, but the actual Protobuf version of that in the binary form would be just an index for each of the keys and then the actual value. So the majority of the payload is actually just data, not spending a lot of it in the preamble or the keys. So substantially smaller payloads on the wire. The nice things about Protobuf is, of course, you get future forward and future backward compatibility. So if the message is of an old Protobuf type, new consumers can read it and backward compatible the other way. Old readers can read new Protobuf messages, so your schema can evolve fairly gracefully. So back to our example, looking at this JSON blob, a quick experiment of turning that into a Protobuf message. So define the same kind of proto message structure, define each field ahead of time, and then taking that what would have been JSON, now turning as a Protobuf blob. Turns out to be under a quarter of the size quite easily. So instead of a 2.5K payload in that example particularly, it's a 400 bytes example because the only data we have on the wire now is just the bytes. But if we wanted to use this for any of our beacon analytics, we've just added another JavaScript library, because if we wanted to encode it, we'd have to bring in either the Google Protobuf.js or protobuf.js, which adds another 20K on the wire. So we're kind of losing what we're gaining. So the question is it worth exploring bringing Protobuf as a first-class citizen, just like JSON encoding is, to be able to get some of these performance benefits on the wire? A few miscellaneous notes here. Yes, we could get similar kind of byte compression with Brotli or other compression algorithms. So the advantage here is that you're in its uncompressed form. It has a lot more byte packing, and particularly with compression streams, while they're available, it's in a web worker, and we've got other kind of idiosyncrasies available there. The other thing to note is that Chrome already has Protobuf as a vendored dependency inside of Chrome, so it's not a net new thing. So the question is, is it worth exploring bringing that up as a first-class API to the browser? So the question I have to the room is if anybody else has explored this topic of using Protobuf for analytics or for other message payloads and seeing similar kind of performance. And are there other use cases, that might be of worth exploring? Any other concerns that others might have? So,
Not a concern, but I just.
So this is mostly a rant about JavaScript loading, but also some ideas on how we can, make it suck less. So humor me. Yeah, a lot of times when talking about web performance, I feel like we're skating to where the puck was, working for Canadians, maybe.
Thank you.
Yeah. But a good chunk of the web is JavaScript, and it's getting worse. And I mean, it's getting bigger, and there is just like it's slow. And there really isn't a good way to load JavaScript. I now work with developer teams and they're like, oh, we're gonna, like, what's the best way to load JavaScript in this particular scenario? And the answer is there is none. But here's some compromise that we can live with. And that has been a recurrent theme for the last few months. So, yeah, we have blocking scripts, and they are obviously awful. That is the worst option because they block the parser, they block rendering, and developers shouldn't be using them. So yeah, let's use async, but async scripts are racy, and there is no real way for like essentially once the script hits the browser will run the script. That may or may not be a good time for that particular script execution to happen. I've seen many cases where making the scripts load faster actually regressed the site's behavior because the async scripts were not critical for the actual content or functionality that the site was trying to optimize for, and executing them earlier made everything slower. There are cases where the inverse is true. Yeah, some scripts are not needed until further down the loading phase. Some of them block UI. There is no way to distinguish between one or the other. And then the third scripts, they are arriving like we know what order they will run at. They are relatively fine. They arrive very late, like they execute very late in the process of the page loading. And they also all execute in a single task, which can get extremely long. Now, I'm not like there are conversations about maybe improving that in at least in Chromium, but that could have side effects. It is unclear whether it is web compatible to change that and have them run in multiple tasks. Then we have ES modules. They have a discoverability problem because by definition, modules are modular, and you load one to realize you need the others, and that creates a waterfall. And we don't start executing anything until we have the entire module tree, which is not necessarily the fastest option. And then we tell developers to cache their JavaScript to like basically cache immutable, and then change the file URL with versions or hashes in order to apply changes to those immutably cached resources. But versioning essentially bubbles up either with explicit ES modules or with when using implicit classic script, and just but you still have scripts that load other scripts. Each reference bubbles up, and especially not versioning, that is like the title is wrong, but people don't use versions, they use hashes. And content address hashes change all the way up the tree, and that is not ideal. Import maps save us from that particular illness, but import maps are fragile. You cannot have more than one at the moment. You cannot have import maps load after modules. And if you have multiple actors, let's say, that are all involved in the creation of the page, that can very lead to breakage. And beyond that, import maps are a blocking resource because they have to be the first thing that is loaded before any one of the modules, and there can be only one. You essentially you need to load a map of all the modules this page will ever see as the first thing in your HTML. That is not ideal. Yeah, bundling improves things because it reduces the number of requests. It reduces, it enables better compression of larger bodies of text. But bundling also has its trade-offs. Once we bundle, every single change in the, every single change in any single file in the bundle invalidates the entirety of it. And bundling also has execution costs because JavaScript doesn't execute until all of it is downloaded. If we're loading a very large bundle, we have to wait until all of it is downloaded until it starts executing. The silver lining here, there have been some progress. So we have blocking equals render, which gives the browser some indication of what that script does and enables the browser to essentially know that this particular, hopefully async script is actually important and should load ASAP rather than later. Fetch priority is also a way to provide hints to the browser regarding the priority of the script. The problem here is that we only have fetch priority, we don't have execution priority. So we don't necessarily know, like we can't presume one from the other, but we could potentially build on top of that. And then dynamic imports are working rather well as a way to lazy load part of large JavaScript apps that are not needed initially or potentially needed conditionally. Yeah, so those parts are working fine. Another pet peeve is that there is no way for language support without UA sniffing. That effectively means that shipping new JavaScript language features and deploying them requires you to either not use them until they are broadly supported by all the browsers in your support matrix, or you need to do some UA sniffing in order to know if you need to effectively generate multiple bundles and send certain versions to certain UAs based on the UA string. Okay, so what do? We bundle. Regarding defer versus async, this is always an open question depending on the context, and there are continuous trade-offs. A lot of people continue to use async despite the raciness for everything that is indeed required early, and then defer or even custom loading for stuff that should be loaded later on, but it's hard and complex. UA sniffing is required, and generally we're not in a good state as far as I'm concerned. Some fundamental issues we have here are like discoverability, at least when it comes to ES modules, is like I said, modules are modular. There are multiple layers of waterfall. When in module state, there is a lot of compression gains to be had because small files compress poorly. Similarly, there is per request overhead that is being paid. And yeah, as far as execution goes, we have to wait for all of them before anything executes. And this is solved with bundles, but bundles are, not streamed and cached. Cache in general and code cache in particular get invalidated fairly frequently. Some of the less fundamental issues is that import maps are blocking, and we don't have enough controls. Like I feel we don't have enough controls for script execution. Controls around download time, around execution time, and like we said the other day, should that script block unload or not? That is something that is, at least in this working group, a pain that's felt. There have been multiple past proposals on those fronts. None of them actually took off. I wrote a thing about resource orchestration a few years ago, and none of it actually materialized other than maybe blocking equals render is some, like one may say that it resembles it. For web bundles and JavaScript serving, again, we had ideas in the past, they never materialized. There are a couple of open HTML issues around, or maybe one of them is closed, but around options of yielding to the event loop between modules to enable execution of a module tree to happen in a more streaming fashion. And proposals around differential script loading to have some versioning in the browser so that the browser would request the right version instead of us having to do UA sniffing. Yeah, none of that happened so far. What do I think we can do better? So one thing we have already done better, and now all that's left is to deploy it everywhere, is compression dictionaries. Because when we're bundling, basically one of the problems is cache invalidation. Compression dictionaries solve that to a large extent on the wire, not in code cache, but as far as like if we're just done the diff, small changes remain small on the network. Dynamic import maps is something I've been working on with Dominic and Hiroshiga and others, and that is effectively changing import maps so there can be more than one, unlike Highlander, and we'll be able to load multiple import maps, not necessarily as the first thing before any modules. That removes the fragility and that removes them as a blocking resource. My main motivation was just correctness, but this also enables us to deliver large JavaScript apps as with multiple phases of import maps instead of one huge one at the top. Module declarations and stream execution is something I've been playing with and failed to create a working prototype as of yet. I am, as part of the prototype process, I also have a hacked version of Chromium that enables you to define inline module specifiers. That is something that I also wonder if is useful on its own, but basically have the ability to import an inline module into a different module tree. I'm basically trying to get that, get stream execution of a bundle in JavaScript. And so far the bottleneck is just that the bundlers are very, I'm prototyping on both the Chromium build and Vite slash Vite and whatever like default bundler it's using, and they are not super flexible. Like most of my issues are on the bundler side, but this is presumably like once I'll have any results from that prototype, y'all will hear about that. This will definitely require some opt-ins, but could enable a more streamed execution way. And then not finally, but we also
it would be great to have per module or per function code caching. As far as I know, at least in Chromium, code caching is done on a per file basis. But if we start breaking up, like essentially sending down bundles, but have modules inside of those bundles, that's not a meaningful boundary. So having that caching be done on a per module, per function basis would be significantly better. I don't know what happens in other browsers, but I'm assuming it's not very different. Yeah, some new keywords for easy loading of scripts to enable non-racy execution that runs earlier than DOM-content loaded. And then finally, for differential script loading, I think it would be great to find some solution. I know that last time we talked about it, we didn't reach any conclusions. So yeah, but this is an area that I think we can improve. And with that, I am out of slides.